Okay, so last time I said I developed a method for innovation that would work with pretty much any type of technology. And the first step in that innovation process was to create something that's known as a mind map. And in this case, I'm using it as a brainstorming technique to sort of organize many different types of technologies. And in the technology that I chose to do this on was synthesizers, because I'm interested in developing new novel forms of synthesis technology. Okay, and so after I did my mind map, I then am going to look at some of the common parameters that came out of that in terms of synthesis, and see if I can group all those different methods under these common parameters. And the ones I came up with were waveform, and we may see there's some overlap between these, but this is what I started out doing. Envelope, filter, and feedback. Okay, and so the next thing is to look at some characteristics of each of these different types of main parameters. Okay, so what are some characteristics that I can organize under? So I could just list out these, and so some of the characteristics I came up with were length, number, and complexity. And under envelope, I could still have the same three pretty much: length, number, and complexity. And then under filter, I still had number and complexity. And this one, instead of length, I went with Q, quality factor, whether it was broad or narrow. And then on feedback, I had number, complexity, and duration. Okay, and so let's look at an example of the waveforms and see how those fit into this. So we'll start with waveforms, and so I know I have, well, I'll just get right into the basic method here. So what I'm going to do is I'm going to make a waveform graph, and I'm going to start out by drawing each of these three parameters as dimension in a waveform space. So I'm going to have 3 dimensions in this case, and I'm going to make a cube and plot each of these parameters along that waveform space. And then what I'm really going to look for is to identify some area of this space and see if there's a point, any area that hasn't been used yet, and that will be where the innovation could occur. Okay, so if I plot this again, this is put length along this axis, and number along this axis, and then this one is complexity up here. So going up in this direction will be increased complexity. This direction will be increased number of waveforms, and then this direction will be something I'm referring to as length, which we'll get into that in a little bit. Okay, so if I look at, so starting off down here in the corner, I'm going to put my good old sine wave. So my sine wave is down here at the origin. And then if I make something a little more complex, that would be maybe a triangle wave or a sawtooth wave. Okay, like that. Now eventually up here in this corner would be something like somewhere around here could be samples, okay, or recordings, and maybe noise or chaos-based sounds that are non-repeating. Okay, so all these would be up in the very complex waveforms in terms of the basic waveform. Now, as I modulate these waveforms, I may have they get a little longer, and so over here I might have pulse width modulation. I might have oscillator sync. Okay, I might have FM and phase modulation. As we get even longer waveforms, we might be going into wave sequencing, a sequence of simple waves repeated over and over. And is that the same as number? Well, not really. I'm actually saving number for ideas like, let's say I have lots of sine waves, simple sine waves, and so that would be, over here would be additive. So a large number of simple waves added together would be additive synthesis, like a Hammond B3 organ, something like that. Okay, and then we could have and these may evolve over time. Wave morphing might be in here. Sweeps, like a filter sweep, would be a longer effect over an amount of time. Granular can come in a lot of places. Let's say you have somewhat complex sound, like a bunch of conversations, or room noise, and you have a large number of them overlapping. So you have a large number of those. Applause might sort of come in here. Although that might be somewhat simpler, so that might be located over there. Okay. Once you map out all of the different types of waveforms you could possibly have, then you look for areas where there are things missing. Okay. So what would have fairly simple, fairly long, but a large number of them. Okay, so over here, so that might be, actually that's really more like your additive on a B3, but actually that's still over here. So if we look at these in terms of wave sequencing, where you have simple waveforms but they're somewhat changing, they only last a short time and you're changing from one to the other and then back again. So you have a fairly long simple waveform that, and then you start overlapping those in a certain way, then you would be in this region. So this area, I don't necessarily see a synthesis method that occupies this point, although maybe you could come up with one. Anyway, that's the basic idea behind the whole method, is to basically first you're going to brainstorm all of the technologies, all the different types of a technology. Then divide it up into some of its key parameters. Select variables and plot each technology into the variable space. Okay, and so you could do something like this for instance, you could do something like this for computer technology. Okay, so you first might mind map out, we had mainframes, supercomputers, you have home computers, laptops, and desktops, and there might be something over here in servers or workstations. Anyway, once you get all these, let's see, laptops, you might go over to PDAs, smartphones, pad computers, etc. And then you might take each of these and map them out in terms of some of their qualities. So maybe one of the qualities would be maybe in your process space, or your not your process space, but your innovation space. When you start mapping these out, there might be power, you might have portability, you might have complexity in terms of number of features. Okay, you may have some other type of cube, or maybe you have more dimensions than that, but I like to keep it to 3 because it gets a little harder to plot if you have more than 3 dimensions. Anyway, plot out each of these computer technologies in terms of this process space, or this innovation space, I'm going to call it. And start mapping them out there and look for where are the gaps in here, where could new innovation occur. Okay, and I believe this should work with any type of technology if you can sort of organize it in this way and then map it out. Okay, that's all I'm going to talk about. Thank you.